All right. What we were doing yesterday, maybe the day before, we were finding the inverse trig functions. What we have today, we're going to have two trig functions, and we're going to find out if they are inverse functions or not. And here's kind of the rule we'll need to use. And we're going to use composite functions. So if f circle g of x is equal to x, so put x there, and g circle f of x is equal to x, then f of x and g of x are inverses. They're inverse functions. Let's write that down. Inverse functions. Okay? I got a couple of examples here. And what we're going to do is do the composite function of f circle g and g circle f if they're equal to x, and we're going to say they're inverse functions. Okay? That's how it's done. So determine whether each pair of functions are inverses. Number one, f of x equals 3x plus 3, g of x equals 1/3 x plus 4. So we want to find f circle g of x first. We're going to find that composite function, f of g of x. All right? Now, g of x is equal to 1/3 x plus 4. So put 1/3 x plus 4 in the f function. So we're going to take the x out, put 1/3 x plus 4 in. So that means we take the 3, keep the 3, we go 1/3 x plus 4 here, and then the minus 3. Okay? And then we'll simplify. 3 times 1/3 x, that is 3 times a third is 1. 1 times x is x. And 3 times 4 is 12. And then we have this minus 3. X plus 12 minus 3. That's x plus 9, which is not equal to x. And since it's not equal to x, then f of x and g of x are not inverses. Okay? You only have to do it once. If you show one way it's not equal to x, then we're done. We can conclude that. All right. Now number 2 here. F of x equals 2x squared minus 1. G of x equals the square root of x plus 1 over 2. So let's find f circle g of x. Okay? That is f of g of x, which is f of the square root of x plus 1 over 2. Okay, so I'm taking g of x out, putting square root of x plus 1 over 2 in. Now, the thing to do here is we're going to take the x out and put the square root of x plus 1 over 2 in. We're going to square that and then subtract 1. Okay? Right here, I should say, is where the x was. Now, what do a square root and square do to each other? They cancel. So let's just put x plus 1 over 2 here. The square root and the square are canceling each other out. And then we have the minus 1 here. All right? Any questions there? Okay. Now, we'll keep simplifying. What do the 2's do here? 2 here can cancel. And then that gives me x plus 1 minus 1. The plus 1 and the minus 1, that's 0. So this is equal to x. Okay. F circle g is equal to x. That's one of the requirements, right? Now we got to show this one, G circle F, which I'll do right here. G circle F of X, that is G of F of X, which is G of 2x squared minus 1. Right? Taking the f of x out, putting 2x squared minus 1 in. And in the g function, it's under a square root. The x is right here, so that's where I'm going to put the 2x squared minus 1. And then I'm going to put the plus 1 here. And then the over 2 here. Right? That top part, square root. The minus 1 plus 1 cancel out. So I got 2x squared over 2. Okay? And let's see. The 2's cancel out. And then I have the square root of x squared, which is equal to x, right? And that's what we need to show. And what we have here are f of x and g of x are inverse functions.